Today on How It's Made, we will examine how HawkSight LGRIN optics are made. Optical lenses have been made from glass for centuries. A new type of engineered metamaterial named Nanoplex is being used to create hybrid optic systems that deliver high-performance, lightweight solutions. The layers of Nanoplex are used to create next-generation optics, leveraging AI technology. Optical lenses are used everywhere in our personal and professional lives, from our phones to doorbells to cameras and in hundreds of other ways. One of the first adopters of these new lightweight optics is the United States military. These optics are used to optimize night vision devices, in fire control systems for mortars, tanks, and artillery, as well as unmanned aircraft systems, drones, and satellites. Nanoplex emerged from research conducted by Case Western Reserve University, DARPA, and the Naval Research Lab. The team from Case Western Reserve studied nano-layered technologies for ballistic shields, which required strong translucent nanomaterials to replace existing polymers. The DARPA team focused on the unique vision qualities of animal species and how those abilities could be incorporated into advanced vision applications. Nanoplex is a family of metamaterials measured in nanometers. To provide context, a human hair is about 50,000 nanometers thick. A sheet of paper, about 75,000 nanometers thick. The second technology is LGRIN, or Layered Gradient Refractive Index. LGRIN is based on the mathematics developed by James Clerk Maxwell. The third technology is Peak's HawkAI software that uses Maxwell's equations to determine how many layers of Nanoplex are required, and then determines the order they need to be assembled in to make a specific lens. Peak's HawkAI software simulates and tests millions of combinations of thin Nanoplex layers to create ideal lens designs. Using this process, a single Peak lens can create hybrid optical designs that can replace and reduce multiple lenses found in traditional glass assemblies. These hybrid optical systems are smaller, lighter, and deliver enhanced optical performance. HawkSight LGRIN optics performance improvements can include a wider field of view, better optical clarity, and up to a 50% weight reduction versus glass lenses. The first step in production is blending plastic materials that start in the form of pellets. These pellets are melted and extruded into precise Nanoplex films with hundreds of refractive indexes for creating lenses. The science of manipulating nanolayers for specific qualities is known as rheology. Peak's patented process involves combining and precisely controlling fluids throughout production. Extrusion machines melt, align, stretch, and spool Nanoplex rolls up to 3,000 meters long. The rolls are then moved to a cutting station that produces millions of 6-inch squares. Once the film is cut, each square is tested and labeled. A barcode is added to designate the unique refractive index of each square. The barcode also identifies each batch. The films are inventoried on their refractive index. The refractive index sorting and testing is fully patented and exclusive to Peak's production process. Producing a lens begins with a robotic process that selects films based on their refractive indexes. Pieces of 6-inch film are layered into stacks. The robots ensure precision and quality control. The stacking order, or recipe, is determined for the robots by the HawkAI software. The recipe is a specific combination of Nanoplex films that creates the required characteristics for each lens. With every layer, controlled airflow is added to prevent contamination and ensure proper alignment. Each stack of films is placed into a vacuum forming machine and then fused into a solid sheet of lens material. The sheet contains the core material that will be used to produce the final lens. The next step in revealing the lens is to cut the newly formed sheet into a circle, much like a hockey puck. Next, the puck is shaped to add the proper curvature for this lens prescription. Michelangelo said, "A sculptor sees the statue inside the marble and then removes the pieces to reveal it." The diamond turning is so precise, it can remove layers as small as 2 molecules. The lens is now ready for testing and validation. Peak's metrology lab validates that the lens has reached its ideal prescription. Then, each validated lens is paired with a housing assembly. LGRIN optics are later incorporated into a wide range of military equipment. Peak's technicians, their Hawk AI software, and patented processes are among the most exacting in the world. Nanoplex products are an excellent example of the intellectual property position that has made Peak a world leader in nanotechnology. Peak is working with the U.S. government, private industry, and suppliers to ensure we produce products domestically and with allied nations that respect IP protections, secure supply chains, and ensure national security. Peak products are designed and manufactured in Ohio. Peak is changing the way optics perform and how they are made to ensure U.S. leadership in optic systems. To learn more, please visit peaknano.com. And that's how it's made.